Hi everyone, welcome to our energy storage class. Today we're going to speak about thermal storage for energy poverty mitigation. So back in 2019, it was estimated that about 1 billion people had sufficient access to electricity worldwide. In 2022, over 41 million Europeans were unable to keep their homes adequately warm. These stats seem shocking for a lot of people, but energy scarcity for electricity and heating is a serious challenge to overcome. Although it's difficult to measure energy poverty as a quantitative number, there have been several definitions of this concept according to the information accessible at the time, based on different indicators. Nowadays, energy poverty can be defined as a household's lack of access to essential energy services that provide basic levels and decent standards of living and health, including adequate heating and cooling, hot water, lighting, and energy to power appliances, resulting in a poor quality of life. In order to mitigate this problem, there has been a lot of effort to develop technologies in the energy storage field to ensure basic energy requirements to the disadvantaged communities.
So what is thermal storage? Thermal storage is a technology that stores energy in the form of heat, allowing it to be used later. It plays a key role in balancing energy supply and demand, especially from renewable sources, by storing excess heat when it's available and releasing it when needed. There are three main types of thermal storage: sensible heat storage, which stores heat by raising the temperature of a material like water, concrete, or molten salts. The energy is stored based on the material's temperature difference, and it's simple but requires large volumes for significant storage. There's latent heat storage that involves phase change materials that absorb or release energy when they change phase from solid to liquid or vice versa. Latent heat storage is more efficient because it stores more energy without requiring a large temperature change. Finally, there's chemical heat storage that uses reversible chemical reactions to store and release heat. It can store large amounts of energy in a compact form and can return heat over longer periods, making it ideal for long-term storage. Thermal storage can help reduce energy costs, lower carbon emissions, and increase energy reliability, making it useful in mitigation energy poverty. But how exactly?
So there are two main kinds of thermal energy storage: passive and active. Passive systems improve a building's ability to regulate indoor temperatures without the use of mechanical devices, being the phase-changing materials one of the most common. This helps stabilize indoor temperature by storing excess heat during the day and releasing it at night, reducing the need for air conditioning or heating. The use of phase-changing materials in walls and windows is the easiest way to apply them to buildings, reducing thermal range inside. Another effective strategy is through ventilation in throng walls. These walls take advantage of air density and convection to warm or cool the air depending on the needs, making them useful for the wall air. This way, passive energy storage is ideal for older, poorly insulated buildings, as they don't require major structural changes, and is suitable either to warm during the coldest months or to cool during the warmer months, contributing to mitigate energy poverty in a wide variety of climates.
Then for the active thermal energy storage. Active thermal energy storage systems improve energy efficiency and comfort in both new and renovated buildings. Integrating with heating, ventilation, and air conditioning systems, thermal energy storage helps manage peak load shifting and reduce energy costs. Thermal energy storage can be used in various building parts like walls, floors, ceilings, and water tanks, offering flexibility in energy management. Then for the applications, a key application of active thermal energy storage is free cooling, where thermal energy storage stores cool night air for daytime use, reducing air conditioning needs. Phase change materials are effective in storing cool air at night for use during the day. Thermal energy storage also works with solar thermal systems to store energy for heating and hot water, particularly through water tanks, which can be integrated into buildings or underground for seasonal storage. Additionally, thermal energy storage with heat pumps shifts energy use to off-peak times, further cutting costs and improving system efficiency. In conclusion, both active and passive thermal energy storage systems offer valuable solutions for improving energy efficiency and reducing energy costs in buildings. Passive systems enhance thermal comfort by naturally regulating indoor temperatures, especially in older buildings, without relying on mechanical systems. Active systems, integrated with heating, ventilation, and air conditioning, and renewable energy, provide more control and flexibility, enabling peak load shifting and energy storage for heating, cooling, and hot water. Together, these technologies can significantly reduce energy demand and lower costs, making them powerful tools in addressing energy poverty. Accessibility, reducing bills, and increasing comfort, thermal energy storage systems contribute to a more sustainable and equitable energy future, particularly for those most vulnerable to energy scarcity. Thank you for your attention.